There has been much public debate in the media and on social media about whether Webb's first images disproved the Big Bang. A particular focus of that debate was an article by Eric Lerner published by the Institute for Arts and Ideas on the 11th of August, 2022, titled "The Big Bang Didn't Happen." That article went viral and has attracted hostile responses from astrophysicists and commentators. The most detailed attack came from two cosmologists, Dr. Brian Keating and Professor Geraint Lewis, in a video posted on Dr. Keating's YouTube channel. I don't propose to comment in detail on the criticisms leveled against Eric Lerner. He can look after himself, and as a longtime supporter of Lerner's evidence and arguments, I look forward to seeing his response. Nevertheless, there are several points I do wish to make. Over the years, I have often drawn attention to the importance of admissions made by mainstream scientists when unexpected results are first obtained from a mission. One frequently encounters unusual candor about the results, falsifying prevailing theories in the first statements and quote, "rush" papers. That is what happened here. The paper was entitled "Panic at the Disks: First Rest Frame Optical Observations of Galaxy Structure at Z greater than 3 with the James Webb Space Telescope in the SMACS 0723 field." Now, Lerner was attacked for not appreciating that the title of Kirkpatrick's paper was a tongue-in-cheek cultural reference, a pun. There is history of scientists giving titles to their papers that include such tongue-in-cheek cultural references or puns. Invariably, such a cultural reference is chosen precisely because it reflects the subject matter of the paper. So another early paper from the Sears Project, this time with the principal investigator as the lead author, reported on the most distant galaxy discovered to date. The title of that paper, "A Long Time Ago in a Galaxy Far, Far Away, a Candidate Z12 Galaxy in Early JWST Sears Imaging." Now, that cultural reference from Star Wars was obviously chosen because it reflected the discovery of a galaxy far, far away. We need be in no doubt that the "Panic at the Disks" title was chosen precisely because it reflected the content of the paper. In its introduction, the authors note the early galaxies revealed by Webb, quote, "have a more normal morphology than expected, with classifications showing that disk galaxies are much more common than previous observations suggested," unquote. And, quote, "the formation of the Hubble sequence appears to be ongoing much earlier than we had anticipated based on Hubble Space Telescope observations," unquote. The authors make three, quote, "key findings." Quote, "The morphological types of galaxies changes less quickly than previously believed, based on precursor Hubble Space Telescope imaging and results. That is, these early James Webb Space Telescope results suggest that the formation of normal galaxy structure was much earlier than previously thought." 2. A major aspect of this is our discovery that disk galaxies are quite common at Z3 to 6, where they make up 50% of the galaxy population, which is over 10 times as high as what was previously thought to be the case with Hubble Space Telescope observations. That is, this epoch is surprisingly full of disk galaxies, which observationally we had not been able to determine before the James Webb Space Telescope. 3. Distant galaxies at Z greater than 3 in the rest frame optical, despite their appearance in the Hubble Space Telescope imaging, are not as highly clumpy and asymmetric as once thought. This effect has not been observed before due to the nature of existing deep imaging with the Hubble Space Telescope, which could only probe ultraviolet light at Z over 3, unquote. These are tantamount to an admission that the pre-existing theories on galaxy formation were wrong, and not just a little bit wrong. Dr. Kirkpatrick was quoted in an article published on the Nature website on July 27, 2022. Quote, "Right now, I find myself lying awake at 3 in the morning, wondering if everything I've ever done is wrong," unquote. Eric Lerner was wrongly accused of taking that quote out of context, bearing in mind that Dr. Kirkpatrick is an expert in the formation of the first galaxies. The Nature article includes another quote that provides the context. Quote, With the resolution of James Webb, we are able to see that galaxies have disks way earlier than we thought they did, says Alison Kirkpatrick, an astronomer at the University of Kansas in Lawrence. That's a problem, she says, because it contradicts earlier theories of galaxy evolution. Unquote. It makes perfect sense that she would be, quote, wondering if everything I've ever done is wrong, unquote. And it's not as if Dr. Kirkpatrick's admissions were an isolated event. For example, on the 28th of July, 2022, a report in New Scientist titled James Webb Space Telescope Keeps Breaking Its Own Record for the Most Distant Galaxy Ever. It states, a team at the University of Missouri claims to have found a galaxy at a redshift of 20, so it would have formed within 180 million years of the Big Bang, far earlier than we expect galaxy formation to have begun. Comments include, our results are completely unexpected and are at odds with all previously favored predictions. And that essentially would break galaxy evolution. If there really is a galaxy at a redshift of 20, it could mean that we have deeply misunderstood the physics of galaxy and star formation in the early universe. The capabilities of Webb are such that it could observe a redshift 20 thing if it were there, but there's a lot of skepticism whether it could be there. Unquote. Scientists like Dr. Keating and Professor Lewis continually tell the public that the evidence amassed in support of the Big Bang is compelling. They dismiss members of the public or dissident scientists who challenge the paradigm. And yet, within the mainstream discipline of cosmology, there is a recognition that the present lambda cold dark matter is beset with fatal problems. This is demonstrated by a very significant review paper on Standard Model Cosmology, published only very recently under the title Cosmology Intertwined, a review of the particle physics, astrophysics, and cosmology associated with the cosmological tensions and anomalies. There are almost 150 authors to that paper, and include such notables as Adam Rees, a 2011 Nobel Prize winner for supposedly discovering the accelerating expansion of the universe and the introduction of yet another epicycle to Big Bang theory, the imaginary dark energy. Quote, the standard lambda cold dark matter cosmological model provides a good description of a wide range of astrophysical and cosmological data. However, there are a few big open questions that make the standard model look like an approximation to a more realistic scenario yet to be found. Unquote. It refers to the need to take into account, quote, the current discordances between the different cosmological probes, such as the disagreement in the value of the Hubble constant, the sigma-8 tension, and other less statistically significant anomalies. Unquote. It states, quote, while these discordances can still be in part the result of systematic errors, their persistence after several years of accurate analysis strongly hints at cracks in the standard cosmological scenario and the necessity for new physics or generalizations beyond the standard model. Unquote. The paper deals at length with the two primary discordances, the Hubble constant and so-called sigma-8 tension. In addition to these, as you can see on your screen, the paper addresses in some detail a long list of additional anomalies that remain outstanding. In a section headed Stepping Up to the Challenges, the paper makes a stunning admission. Quote, in view of the accumulation of the lambda cold dark matter tensions discussed in the previous sections, it is becoming apparent that the need for a new standard cosmological model has been increasing during the last few years. The present time has similarities with the late 90s, when it was becoming apparent that the standard model of that time, flat standard cold dark matter based on the Einstein de Sitter model, had been accumulating a range of inconsistencies with data, including indications for excess clustering on large scales, hints for omega m less than 1, age of the universe tension, velocity flows, etc. Unquote. It also makes a glaring admission about problems presented by the cosmic microwave background that Dr. Keating apparently regards as unassailable proof of the Big Bang. Quote, meanwhile, The cosmic microwave background temperature map has a number of independent pieces of evidence, each with p-values less than 0.3%, i.e. less likely than a 3 sigma fluctuation, that the lambda-cold dark matter prediction of statistical isotropy is violated. These cannot be addressed by mere changes in the background scale factor dynamics. They demand early universe or large-scale departures from homogeneity and/or isotropy." Unquote. It's hard to overstate the significance of these admissions. Don't let people like Dr. Keating and Professor Lewis and their camp followers tell you that the evidence for a Big Bang is compelling and settled. Claims like that are demonstrably false. I now comment on an attack on plasma cosmology made by Dr. Keating and Professor Lewis. There's an unfortunate confusion that arises in relation to use of the word cosmology. The Merriam-Webster dictionary tells us that the word cosmos derives from a Greek word and means universe, or more specifically, quote, an orderly, harmonious, systematic universe. That the word cosmology is defined relevantly as, quote, a theory or doctrine describing the natural order of the universe. The same dictionary tells us that a different word, the word cosmogony, means, quote, a theory of the origin of the universe. There's been a growing tendency in both the technical literature and popular science to use the word cosmology to refer to the study of the origins of the universe. Cosmology, as traditionally defined, is much broader and is concerned with explaining all cosmic phenomena. Thus, the Cambridge Illustrated Dictionary of Astronomy notes that, quote, cosmology in the broadest sense covers physics, astronomy, philosophy, and theology, because it aims to assemble a world picture explaining why the universe has the properties it has. Unquote. Plasma cosmology, also known as the plasma universe, has that broader focus. It is fundamentally concerned with the behavior and role of plasma in the universe as we observe it. The electric universe generally relies upon plasma cosmology in connection with the behavior and role of cosmic plasma. However, the electric universe has an even broader focus and extends from the level of the subatomic to the largest structures in the universe, and extends in particular to disciplines such as geology, biology, and atmospheric physics. The electric universe also differs from plasma cosmology on a number of fundamental issues, including in particular gravity and the source of stellar energy. Dr. Keating and Professor Lewis engaged in a contemptuous dismissal of plasma cosmology by equating it entirely with Klein-Alfvén cosmology, sometimes known as Alfvén-Klein cosmology, or, quote, symmetric cosmology. That cosmology is based on a hypothesis, first proposed by Oscar Klein, that the universe contains equal amounts of matter and antimatter. It was further developed by Hannes Alfvén in the 1960s as an alternative to both Big Bang and the steady-state cosmology proposed by a group of distinguished astrophysicists, including Fred Hoyle, Tommy Gold, Herman Bondi, Jeffrey and Margaret Burbidge, and others. Keating and Lewis claimed, citing an article by the astrophysicist turned science commentator Ethan Siegel, that plasma cosmology was disproved a year before it was first proposed. Alfvén's most important later work, his 1981 book Cosmic Plasma, is overwhelmingly concerned with the behavior of cosmic plasma in our present universe. It is only the last chapter that deals with cosmology in the sense of the origin of the universe. Further, Alfvén made it clear that his was a tentative proposal for consideration in the event that the evidence against the Big Bang became decisive. He stated, quote, in recent time, there has been remarkably little discussion of whether the basic Big Bang hypothesis is correct or not. Because of its obvious advantage compared to the continuous creation model, it was generally assumed that it must be correct. Authoritative presentations of the modern view of the evolution of the universe, for example, Sciama and Weinberg, take for granted that no other views are worth considering, as does the majority of the cosmological establishment. Observations are primarily interpreted according to Big Bang formalism, and the large body of observations which are not in agreement with it are either accounted for by numerous ad hoc hypotheses or simply neglected. If the Big Bang theory is shown to be unacceptable, it will leave a, quote, cosmological vacuum, which necessarily must be filled by another approach. One of the candidates is the Klein model, which is based on the Dirac symmetry between matter and antimatter. This approach is of interest only if our metagalaxy is symmetric with regard to matter-antimatter. There is no absolutely convincing proof of this, but there are a large number of strong arguments in favor of this view. However, it should be stressed that the criticism of Big Bang is largely independent of the arguments in favor of the symmetrical approach." Unquote. The leading plasma cosmology textbook, Tony Peratt's Physics of the Plasma Universe, contains nothing at all about the origins of the universe. It makes no mention of the Klein-Alfvén theory. The word antimatter does not even appear in that book. The premise of the Keating and Lewis attack on plasma cosmology is that it is equivalent to Klein-Alfvén cosmology. That premise is simply false on the face of the primary sources. Their contemptuous dismissal of plasma cosmology amounts to an appalling straw man argument. They are either entirely ignorant of plasma cosmology, or they were being deliberately dishonest in equating it simply with Klein-Alfvén cosmology. But that is par for the course when it comes to critics of plasma cosmology and the electric universe. At this point, it's necessary to say something about the scientific method. Contemporary philosophers of science are unable to agree on precisely what the scientific method actually is. Reflecting the current sorry state of the philosophy of science, the Stanford Encyclopedia of Philosophy entry for, quote, scientific method commences with the observation. This entry could have been given the title Scientific Methods and gone on to fill volumes. Or it could have been extremely short, consisting of a brief summary rejection of the idea that there is any such thing as a unique scientific method at all. Scientists themselves usually don't have any trouble identifying what the scientific method is. For example, the late Stephen Hawking, a high priest of the Standard Model, provided an admirably concise statement of it in his best-selling book, A Brief History of Time. Quote, "Any physical theory is always provisional, in the sense that it is only a hypothesis. You can never prove it. No matter how many times the results of experiments agree with some theory, you can never be sure that the next time the result will not contradict the theory. On the other hand, you can disprove a theory by finding even a single observation that disagrees with the predictions of the theory. As philosopher of science Karl Popper has emphasized, a good theory is characterized by the fact that it makes a number of predictions that could, in principle, be disproved or falsified by observation. Each time new experiments are observed to agree with the predictions, the theory survives, and our confidence in it is increased. But if ever a new observation is found to disagree, we have to abandon or modify the theory. At least, that is what is supposed to happen. But you can always question the competence of the person who carried out the observation. Here is Richard P. Feynman, arguably the most beloved and admired physicist of the second half of the 20th century, explaining the scientific method in one of his famous lectures.
Now I'm going to discuss how we would look for a new law. In general, we look for a new law by the following process. First, we guess it. Then we well, don't laugh, that's really true. Then we compute the consequences of the guess to see what, if this is right, if this law that we guessed is right, we see what it would imply, and then we compare those computation results to nature, or we say compare to experiment or experience, compare it directly with observation to see if it works. If it disagrees with experiment, it's wrong. And that simple statement is the key to science. It doesn't make a difference how beautiful your guess is. It doesn't make a difference how smart you are, who made the guess, or what his name is. If it disagrees with experiment, it's wrong. That's all there is to it.
If the scientific method were being applied properly, then the foundational axiom of the Big Bang, the interpretation of cosmological redshift reflecting an expansion of the universe, would be treated as falsified. However, that is not how science works in practice. The Big Bang has become what Thomas Kuhn would call a paradigm. Kuhn was the most influential philosopher of the 20th century. He noted that once paradigms become established, normal science proceeds by way of, quote, problem solving within the paradigm. Anomalies are either not seen or are ignored until that accumulates to the point where a revolution is possible. The continuation of the paradigm in the face of contradictory evidence is termed paradigm paralysis. Imre Lakatos proposed an alternative analysis that also gained substantial support. Big Bang Theory is a classic example of what Lakatos would call a, quote, research program, constituted by a bundle of core theories supported by many auxiliary hypotheses. But those core theories are presumed to be correct and are not open to question unless and until the research program becomes, quote, degenerate. We can look forward to the addition of more epicycles to accommodate the discordant observations coming from Webb. Standard model cosmologists will invent new theories of star and galaxy formation in an attempt to save Big Bang Theory. This will merely be the latest example. Dark matter, inflation, and dark energy were each epicycles invented to save Big Bang Theory from intractable problems prevented by observations. The careful and courageous commitment to the evidence that Halton Arp displayed for decades until the end of his life has finally seen him vindicated. Halton Arp, the Galileo of Palomar indeed. But don't expect the standard model astrophysicists to abandon the Big Bang. They are under the sway of a deeply entrenched paradigm. They are not able to see this evidence for what it is. A flat-out contradiction of the core foundational pillar of the Big Bang, the very foundation of an expanding universe. In conclusion, it may be that Hannes Alfvén's long-predicted crisis has arrived. Edwin Hubble's skepticism of the expanding universe is vindicated, but his idea that, quote, new physics, now driven by Nobel Prizes, is not required, but rather simply a return to natural philosophy and classical physics. Mathematics is merely a descriptive tool to be applied to real physical models. The unfathomable opportunity loss of our instinctive inability to learn from the past will only become apparent when the metaphorical book burning of Immanuel Velikovsky's classic and well-researched Worlds in Collision in the 1950s is acknowledged by modern astronomer priests as a fundamental error. As a classical scholar, Velikovsky saw repeated patterns in the earliest creation stories of mankind from around the world. He applied our modern understanding of astronomy to those stories, and found the belief in Newton's clockwork planetary system unable to explain the erratic behaviors of the all-powerful planetary gods, and their strangely pictured thunderbolt of the gods' weapon. He threw down the gauntlet of our understanding of gravity. It was only picked up by a handful of scholars. I accepted the gauntlet before entering university, and it became a lifelong quest. Isaac Newton, in a letter to Robert Hooke in 1675, wrote, "If I have seen further, it is by standing on the shoulders of giants." However, it is essential to first find the historical giants facing in the right direction.